Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book that made it possible. I always start class with a quote. Here we go with the quote of the lesson. It comes from Gary Whittington, my mentor and a best friend. You can't outrun your training or the weather. I think about these words quite a bit as far as running goes, but these words are also relevant to any kind of training, including the kind that you're doing as you work to acquire the specific knowledge that is the mathematics of finance. The focus of this lesson is the future value of an ordinary annuity. An even annuity is made up of frequent payments that are level or even in terms of amount and timing. Now on the slide, notice how the OA for ordinary annuity is in parentheses. Why? Because this is calculated using the FV key on your financial calculator. The notation relates to the third window of the TVM wallet, as we'll see when we work through the real world example. As far as timing is concerned, the future value of an ordinary annuity is as of the timing of the last payment in the series. In the last lesson, we mentioned how the PV and FV keys on your financial calculator are used to solve for the present or future value of an annuity or perpetuity. Since I do not teach people to use begin mode, this means that the FV key will also be used to calculate, get ready for this, the present value of an annuity due and the present value of a perpetuity due. That's not a typo. This intermediate operation on the financial calculator does the same thing as the add-on expression in the building block present value of an annuity due equation and the building block present value of a perpetuity due equation by moving the value one period to the right. So why don't I advocate using begin mode? Well, I've talked about this before, I've written about this multiple times, and I have a future lesson teed up exclusively for this topic. But if you want to read more about my thoughts on begin mode and you just can't wait until that future lesson, feel free to visit our blog at boxhomepress.com. So here's the real world situation for this lesson. One thing to point out, just because the PMT payment happens immediately does not mean that this is an annuity due. Remember what differentiates the building block future value of an ordinary annuity equation from the building block future value of an annuity due equation? It's the add-on expression, 1 plus I, and I is the true investment yield, in parentheses, which moves the value one period to the right. In other words, the last PMT payment in the series gets to go to work earning a return, while all the other PMT payments in the series get to go to work for an additional period. What appears to be an annuity due just might be an ordinary annuity in disguise, and vice versa. Let me say that again because it's so important. What appears to be an annuity due just might be an ordinary annuity in disguise, and vice versa. This is where it pays to have knowledge of the building block time value of money equations and the purpose of the add-on expression. So let's draw a TVM wallet. And we'll get to analyzing and evaluating this real-world situation. So we're going to draw the TVM wallet. Remember, the TVM wallet is meant to be used in conjunction with your financial calculator. So wherever you are, if it's at home or somewhere else, I hope that you also have a financial calculator close by. as you're drawing your TVM wallet. Let's put an OA in parentheses here because we're solving for the future value of an ordinary annuity. In the first window of the TVM wallet, let's draw our timeline. This is an abridged timeline. This is the abridged symbol. Sometimes I forget to draw that, but hopefully you know what we're getting at here. So that's an abridged symbol, which tells us that whatever payment happens right before the abridged symbol continues through that period of time. So we have 25, that's right, 25 $1,000 PMT payments in this series because the first PMT payment happens immediately. Put 0 for PV because there's no lump sum that we're analyzing here. We have to figure out how we're telling time. But let's go through the 3-1-2 warm-up routine. Time, value, money. 1, 2, 3. So let's start in the third window of the TVM wallet, and let's talk about money. More specifically, let's count money. We're dealing with a PMT payment here of $1,000. So a PMT payment is an annuity. Okay, great. We know that we have a payment that is frequent. And what is that frequency? Let's move on to the first window of the TVM wallet that relates to TVM rule number 1. How are we telling time between time periods on the timeline? This is a monthly time span in between period markers. So we're going to put an M down here to remind us that we have 25 payments in this series. Only a true monthly investment yield is going to work. That's the only rate that's going to fly. So we need to solve for the true monthly investment yield. Up here, I'm going to write the building block true investment yield equation. And then we're going to solve for the true monthly investment yield. We were told that the simple, and remember simple is another word for nominal, which just means that the effects of compounding are not considered. We were told that the simple annual investment yield is 4.25%. So we're going to write that here in decimal form, 0.0425. We were also told that compounding happens monthly. So lowercase c takes the value of 12. Okay, let's take this from the top. S is what I call the caterpillar rate. Caterpillars don't fly. When we get to the chrysalis rate, a chrysalis doesn't fly, but a butterfly flies. And so we're after I, which is what I call the butterfly rate. And the butterfly rate that we're looking for here is the true monthly investment yield. So let's start with the caterpillar rate. That's 4.25%. We've written that here in the decimal form. We were told that compounding happens monthly, so compounding is going to happen 12 times over the annual duration of that rate. Within parentheses, we have what I call the chrysalis rate. But let's put more words to this. Let's call it by name. When we divide a simple annual investment yield by 12, what are we left with? A simple monthly investment yield. That's really important. That's our chrysalis rate. It's a simple monthly investment yield. Notice how we don't even need to know that exact number right now, because we ultimately want to take what is our chrysalis rate, that is a simple monthly investment yield, and turn it into a true monthly investment yield. And when we know that lowercase n takes a value of 1. When we work this out, I'm going to give myself a little more space here. When we work this out, we get 0.00 3, 5, 4, 1, 6, 7. We'll take it all the way out, which is 0.3541667%, which is a true monthly investment yield. That's the butterfly rate. That's I. That's the only rate that will fly. Why? Because we're matching that with the time span in between period markers. That's why one of the first things we do is we fill in the blank above the timeline. And when we solve for, well, before we do that, let me write this in. In my trusty HP12C, I need to input the percentage format for the true investment yield, I. So let's solve for the future value of an ordinary annuity. And when we solve for the future value of an ordinary annuity, we get $26,000. Let me make sure I get the right number. $91.92. So there we go. Now let's interpret signs. And I want to focus on the third window of the TVM wallet. Why do we have what I call a positive no sign value associated with the PMT payment? Well, because monies are going to be flowing into your hand. You're going to be receiving the monies. That's what the positive no sign value is all about. But what about the negative sign associated with the future value of an ordinary annuity? Well, let's think about this for a little bit. Because if you received $1,000 every month and you deposited those monies or you invested those monies and your true monthly investment yield was 0.354167%, then at the end of this 24-month period of time, it's expected that you would have $26,091.92 in that account. That's where the negative sign comes from, because those are monies that would be invested, that you would have on deposit or in an investment account. So let's move on to the double check. And no surprise, we're using the building block future value of an ordinary annuity equation to double check our work. The future value of an ordinary annuity equals the PMT payment times all of this in the square bracket. 1 plus I, that's our true investment yield, raised to the power of n, that's uppercase N. And in the denominator here, we have the true investment yield. Now we know that we're using a true monthly investment yield. The future value of an ordinary annuity equals $1,000 for the PMT payment. That's a known value. Remember, we're trying to solve or double check the work for the future value of an ordinary annuity. 1 plus 0.0354167. You may be wondering, how far do I need to take this out? And I guess it just depends on, well, I think you should at least go, 4 or 6 places to the right of the decimal point, but I guess it just comes down to what kind of rounding error you want. And I want to be very precise here. And so that's why I'm going out 1, 2, 3, 4, 5, 6, 7, 8 places to the right of the decimal point. I normally write them out 6 places, but today is a little different. Let's fix that 5. Okay, and when we solve for the future value of an ordinary annuity, we get, I'm happy to report, it's the same number, $26,091.92. So that is a value that we can circle. We've double checked our work. at least one thing to point out here. Notice that the future value of an ordinary annuity, the value on this slide, has what I call a positive no sign value associated with it. Well, how can that be? Because in the TVM wallet, we saw a negative sign. Well, it's because whenever you're dealing with building block time value of money equations, yeah, you're going to see a minus sign. We see a minus sign in the numerator within the square brackets, but you're never going to see a negative sign associated with a PV payment, an FV payment, or a PMT payment. That's just not how it works. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Studying or training that includes the building block time value of money equations can save you from making a mistake and a hard lesson that could have long-term consequences. In the book, Would Your Boomerang Return, I share some of my experiences, including the easy lessons and the hard lessons that I've experienced in practice. My hope is that you will potentially limit your exposure to hard lessons by learning from experiences that were far from my finest hours. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.